Welcome to class. So,
Welcome everyone. That is is a contemporary object-oriented programming language developed by Google. It is designed for building high-performance applications across all various platforms. Key use case, what we use that for. The first one is actually Flutter applications. It is a primary language for creating beautiful and fast mobile, web, and desktop applications. That backend server. That also power server logic with framework like Flink that enable full stack development in that. Locally type and compile. It ensure reliability and performance with compile time check and optimize execution. Type that. Now let's look at how to get started with that. First we need to do, we need to install that SDK. Now for our class, we can just install that SDK directly. But I love installing it with Flutter because it includes that automatically. But today I'm going to just install with that because it just requires just one command and that's so if you need any other process, any other way to learn to record the install, you can message me and I will help you with that. So we have what is called first thing that is called that.dev. Read about that here and look at what that is all about. That is very portable and very fast and it's very good to use when it comes to server side logic, mobile app, and it's on all devices. Now, where you need to just go is to go to get that like this. So when you go to get that, you check your system requirement to see what you can use and a lot of system of nowadays can actually install that. All this one are old system, that's why they cannot install it. So now where you need to go to, you say you can install that. This also is showing you the option you can use to install that. So manager and that is what it's recommended for us to use. So we just come here. So if you are on window, what you need to just do is just type shoko install that and that's all. What that going to be. That was going to that's immediately what's going to happen to you. If you're on Linux, you just need to copy a lot of command. You install this HTTP first, you install this, then you do this and that. When you are done, that will be installed on your phone on your system. This macOS, you just copy this uh, build command and put it here. Or yeah, install that. That's how to install that. Now, if you want to install with Flutter, you just need to go to Flutter SDK like this. Here, you come to Flutter here, you look at instruction on how to install it. So you can just say, quick one, you go to your SDK, you install it, you can download manually, but I like that. I like download manually and set it up myself. Download manually like this and you set it up. And that is not hard. Let's just show you how you can do that, how you can install on window. Just need to come to window here, open your here, you copy it, and from here you open what is called your PowerShell like this, and you paste it here. You press enter. When you press enter, it will install it for you automatically. You just need to wait and it will install it for you automatically. Now, to be sure that it's actually have installed, you just need to come here and say, I've already installed my own. Say PowerShell again, or you say PowerShell again, or control panel CMD, control panel like this. You say that's V version. Sorry. So when you have this, so guys, it has given me the version that I using. So that is how to install that, and that's what to do. After that, that's to open. You open your terminal or command prompt to check to verify your data. Let's start our first program. To start our first program, we need to write this small program. So first that program should be hello dat. Now let's do that. So first we are going to create a dat 10 mastery like this. Then you create week 1 in it like this. So inside the week 1, now you're going to open it in your VS Code. Okay, CMD like this. Then you could just create the folder you want to create your file. You press code space dot down. By pressing code space dot, what does that do for us? What that does for us is that it opens our file in VS Code. It opens our file in VS Code. Now, what we want to check here, you need to create what is called a main.dat. Create a main.dat file from this folder here. But before we create a main.dat file, what you need to do first is to come to the extension here. Ensure that you have that installed in your file like this. You search for that and you install it. Ensure you have that installed in your VS Code like this. So after that, you come back to your file, you create main.dat. Now, what actually make you to know that you have already created a file that is that file is by the extension that you add, which is this extension that is here. That is here. So what we need to do, let's just learn what we need to do. First thing that we need to do is that we need what is called a return type. This to indicate that main function, we have what's called a main return type, which indicates that main function does not return anything. So we need to add what's called a return, which is void. Then we have what's called main. Then we have parentheses and curly braces. And this actually indicates that our main function that we create here does not return anything. And main function that we create here is an entry point for that. This is where every Dart program begins its execution and it starts a line for your code. So they have another thing called a print, which is here. So I'm going to say print that. Here, so print that. Hello. That. So now this is how you create your application. The first thing we need to do is to compile our application. So you have got that compile, that compile exe, then what's my main dot that. Now if we compile like this, it's going to create a file called this file for you. Now if you have compiled it, what you need to do is just have dot /main like this .exe. Now this is going to open what you have compiled for us. Now what happened now is that that is compiled into native language, which is the exe. Now when we look into the exe, what is inside of it is just a hello data we have here. So we can also add an additional things to it by saying hello world print hello world. So you can now we need to compile it again before we run, because if you try to run it, it's not going to be there. So we need to compile it again and we run it again. You can see it's now there. So that's how to compile your application and print to the statement. Now you have actually write your first code. Just like in C or C++, int main or Java public static void main, the main function serves as a crucial starting point for your application. So if you don't have main function application in your application, that will not know where to start running your application. So the first thing to have in your application is to have this main function, and main function is your entry point for your Dart program. So let's continue. Now we want to talk about understanding comments. Now let's look at what is called comments. Comments are essential for making your code readable and understandable, not just for others, but for your future self. That offers several ways of adding comments. But one way that offers is we have what's called a singular comment, which means I just need to do what is called // the double forward slash like this, I will, and I will comment there. So the first thing is that we have this is single line comment, can you see? And it explain the code on one line. So now I'm going to explain this my code that is here in one line. I'm saying we have first thing that we have is called return type. The second thing we have is function name. The next thing we have is parentheses and curly braces. So I have explained this my function that I have here in a one line. Now then now we have is what's called multi-line comment. Multi-line comment. So what we need to do, maybe assuming that we want to write a lot of logic. And what we need to do is have forward slash asterisk, then to stop your asterisk forward slash. So forward slash. So anything that I write in the middle here is going to be a comment. I said this is multi. So we can see that we can write anything that we want here, and this will affect everything. So that's multi-line comment for you. Now we also have another thing that we may need to learn. It is called document comment. These two guys are called document comment. So this is multi-line document comment. This is multi-line document comment. This is how you do multi-line document comment. And if I don't put anything, everything is already comment. Now this is single line document comment. Now what this document comment does for us is that what this document comment does for us is that you can actually generate HTML from this document for your application automatically. So this guy is going to this HTML is going to explain what you write in your application and how you write it based on what you put inside of this place. So that's what the comment does for us. Now note that comments are ignored by that compiler, but they are invaluable for human comprehension. So they serve as guide and help you and your team to navigate the complex logic and record the purpose of the specific code section. So when you write a code, so use comment to actually explain the purpose of the code and what the code should be used for, or what the code is doing in your section. Now let's look at what is called variables and data type. Now variable are fundamental to programming, and they act as container for storing data in your computer memory. That provides several built-in data type to handle different kind of information. But one thing we must not note is what we call integer. So we have now the next thing we need, and this is how you create a data type. So let's use our integer as an example. We have what's called int, which is our data type. Then we have what's called the variable name, which is age. Then we have the value assignment operator. Then we have the value, which is 10. So this is what we call variable. So you can print your variable. Now when you print your variable, what will happen is that it's going to your age it's not going to give us age. It's going to give us the data that is assigned, that is saved inside the age. That's what it's going to give to us. So let's have what is called compile it and let's run it. So you can see it gives us a 10. So let's draw that. So we have what's called double. So let's do the second one, add double is equal to 40.6. Then you can also print that, print height. So the next thing we want to look at is also called, let's check, it is called name. The name has to be string first. Name is equal to aim. So we can also print that. That was called aim. So let's print that. Now name. Then the last thing you need to learn is what's called Boolean. Bool. So you can say is student is equal to false. Now this take either true or false. Print it is true or false. Now this take either true or false. Now we have what is called a integer. You take a whole number, double take a decimal point number, no number that have a decimal point, maybe floating number. The name, a string, take a sequence of character like text, and for Boolean, it take what is called true or false. Now, that memory management simplified the development. When a variable is no longer in reference, is no longer referenced, its memory is automatically reclaimed and prevents memory leaks and optimize for performance. So let's look at how that intelligent memory management, how that intelligent memory management. One of the that powerful features is automatic through garbage collection. This means you don't have to manually free up memory and this simplify development and reduce common errors. Number one thing that uses is what's called stack local frame. The next one they use is heap by allocating objects. We have what's called object in and out, garbage allocator sweeper. So let's look at the first thing we need to look at. Now we can also read this. So if store objects such as list, map, and string, and this object can be very lifetime. So stack memory manage what is called functions call primitive variables and follow a strict lasting first out order. So garbage collector continually monitor the memory, identifying and removing the objects that are no longer accessible by your program, effectively keeping your memory clean and efficient. So what is stack programming? A stack is a fundamental data structure that operates on a lasting first out principle. In programming, this most common application of stack is called a stack fundamental data structure that operates a stack is a fundamental data structure that operates on last in and first out principle, which is LIFO principle. In programming, the most common application of a stack is call stack, which is crucial for managing function calling during program execution. When a function is called, that's a stack frame, also known as a activation record, is created on a stack. So when a function is called, a stack frame is also created. So the stack frame store essential information for the execution for function execution, like if variable declared within the function, argument passed to the function, and return an address and indicate where the program should resume executing after the function completes. So when the function finishes its execution, it corresponds stack frame, it pops off the stack automatically, freeing up the memory it occupies. So look at what's called local frame. A local frame is essentially a stack frame specifically designed to contain the local variables and execute context of single function call. Each time a function is called, that creates a new local variable, a new local frame, and push it into the call stack. So variable declared inside the function only exist within the specific local frame. These variables are automatically destroyed when the function returns and its frame is popped off the stack. So I want to look at example here. So now I want to copy this code and put it into our project. So we're going to create a file called stack example, and we're going to copy the code and paste it there like this. So first thing we need to look at this guy. this name, this integer, then this is our integer, and this is our x, which is the variable name. Then we have 10. Now this is our main, this is our what's called a frame, this first frame. And the first frame, the main frame that we have is main. Now inside our frame, there's a stack memo that is being created. Then there's a stack memo that is being created. So I'm going to use a stack as a list. Let me have a list of value. So first thing that I create here is actually what is called this guy, the x. The next one that is created, the new frame is created, which is what is called this value that is here. So you create another value that is called new frame. So this one, number one, that is here is the x. This one is the function. So this one is the function. So, or let me just clear everything. So I'm going to have it on the vertical order like this. So the first one that we have here is what? This one is actually the x that we have. The next one that we have is what is called the function. So now, what does that mean? So that means that we have two stack. This is stack, all this is stack, our stack memory, and we have two data inside our stack memory. Now, when this guy comes in like this, when this guy comes in, he comes into this guy. So this is a local variable. We have another local variable here that is created inside the frame. So there's another frame created here for this guy. Now, another frame created here for this guy. So what this frame does is that as soon as you do what's called int double is equal to value as 32, then you print the double. So that actually print out the value, and as soon as you are done from here and you come back here, now when you come back here under this place, so your stack gets removed automatically. So as soon as you are done from this guy, the stack gets removed. So when you are done with it, the stack gets removed. If there's nothing to do again also in your memory, this also gets removed as soon as your main function is executed. So the one that you put last is the one that gets removed first. So now if I have if I have something called like this, say print x like this. So what's going to happen here is that, let me run it. Let me compile. Oh, sorry, this is not. I can't compile this. I can actually compile it, but I don't want to compile it. So what I want to do here is that first thing is going to run. This one is going to run first. Yeah, this one is going to run first. Then it's going to call on this function. When it's done with this function, the function is going to double it times 2. Now when it's done with this function, it's going to come back to this print x. Now that's that the x has not leave this x, or this frame have not leave the stack. This frame have not leave the stack. This frame that is here have not leave the stack. But as soon as this print value is done, it left the stack. But this frame, which is the new frame that we created, can still be accessible until this function is destroyed. So if the main, maybe as soon as we run the main, it's run and it's finished, this guy also is going to be destroyed by garbage collector. So garbage collector is going to take that and free our memory from it. So now look at it. So when you initialize your main function, is created and pushed onto the stack inside it, x also is initialized with to 10. So when print value is called, a new frame for new value is created and pushed into the top of the frame in main. So into the new frame, the value is 10, yeah, and into the new frame now, inside the new frame, sorry. So the value is 10, yes, and the double becomes 20. So after print value finish, it tags print what's called 20 and it's framed top of the stack. So now, and the local variable are destroyed automatically. As soon as it is done, you print it. That's with the finish line of this double. So execution return to the main function. After the main function completes, its frame also pops off and the program ends. That's how it works. So the memory that this guy is occupying, as soon as this guy is done, is going to be removed automatically. And then let's look at what's called why local frame matters. So local frame, number one, is for memory management. Local frame and other memory are automatically allocated when function is called and they are allocated when it's returned. This prevents memory leaks and simplify development. And that thing is for reason why we need to do it is because there is something called debugging. So when error occurred, a stack trace show the sequence of active function call, and stack frame they lead to the error and make it invaluable for identifying the source of the issue. Now let's copy this guy and see what we are trying to do here. Now we're going to run this. There's no way we're going to run this, but you're going to see error. So let me copy this. So you go to your debug mode here, and I want to create what's going on from here. Now look at the error that we have. Now if you look at this error, first thing we know is that there is error that we have is that integer division by 0. You cannot divide integer by 0, and we are doing that here. That's number one error that we have. But where does the error occur? Look at it. We have what is called inline. In our core part, in the that error now. This is what you see. So we go to that and look at integer. Then in the core part, we go to integer dot that. You will see that in line 7, this is where the rules is being made. Now in our trace here, the second thing you need to trace is that in our own file, which is file, look at where your file is. You need to have your name and your stack example here. In line 11 in line 11 to 12, where you end in 12, but it is the error itself is actually in line 11. Now in line 11 you are trying to do this thing. Now that is not all. This function is actually called inside your main function. Can you call the main function here? So this is what we call tag trace, and it's actually because it actually understands the sequence and how it study everything in the stack. That's why it actually can be able to get this kind of error or can allocate or get this kind of error. So now you know that in main file, where are you calling this division? Where you are having the error, you are calling this division in line 3. Can you see 3? And you are caching it in line 4, in line 5. So that's what is expected from you. So what I'm trying to say now is that this error that you see is the reason why you can get is because it's using memory to manage where the function is and how it uses them. So the stack now, can actually be able to trace them by caching the error. Now you might not understand try and cache if you are very new to this thing, but don't worry, you are going to actually see more of it. Now if you run the above code attempting to divide by 0 will cause an error, and catch block will print a stack trace similar to this. And this output shows that the call of stack at the moment. So that's what I wanted to see. It showed the way you call all these things. You can see divide was called by main and giving you exact sequence of function call, and the number and represent the position of each frame in the stack, with 1 being the innermost and most recent call. So that's how it is. So you can see that the value are called and they're showing based on where the file is in your frame. So you must not forget that. So what is heap? What is heap? So a heap is a regional of memory used by dynamic allocation, unlike stack. So stack just store all those things in the file and everything. Now, heap memory in heap is not automatically free when function return. Memory in heap does not automatically free. So object store here persists until no reference point to them. So now what happened that anytime you store something inside the heap, so this kind of object or this kind of data, they are persistent till when it does not see anything that reference to them. Maybe there's no pointer to them, nothing is pointing to them. So at which point that garbage collector now reclaim the memory from them. You now take them away, put them away, and reclaim the memory, free the memory for us. Now allocating objects in that. So let's copy this guy and actually see what we are saying. So we create a heap.dat here. So we are going to copy it like this. Now when it comes to heap, now when we run this function like this, now if I run this function here, it's very easy for us to like see what's going on. Now we can't see, we won't be able to see anything actually, but nothing is going to be printed. But what happens is that as soon as we start running this program, this guy is actually created. But now this guy is created, and this what is created is inside our heap, and this guy is inside our trace. Now as soon as we start running our main, the trace link to the heap, you might not actually understand now. So this trace leads to the heap, and we can actually access it from our function. But what happens is that this guy is saved in our heap until our code is not running again. So if our code is still running, we can access it anywhere and anytime. Also, if you want to actually really access this guy anytime and anywhere, if you put it here, now this person, as it creates inside the heap, it also creates on a stack of main. Now if you don't use this guy inside of this page, if you use another function entirely, this guy is going to create this one that is here is a global function, and is created inside of heap, and is not on stack at all. Now this one, as soon as you create your project, you run the project, it has been created, you can only access it by just calling this p. So anywhere you are, if you call this p, it's going to access it automatically. That's what we call heap. Heap store a data that is persistent in the memory. So now when you create an object using new or just by calling a constructor in modern that allocates it in heap. Now in example above, p is a reference store in a stack. Can you see what that was I say? So p is actually stored in a stack of main. If you bring it back inside the main, that's our reference object. Stock in a stack of main. Know that it's a frame created that's called main. Now, and person is an object store. Now the each object that is stored is inside the heap, and this object that is stored inside the heap is actually like this our stack now points to the object that is inside our heap. Now the object that is lost here, basically after the function finished, the object that is lost here is actually the p that is lost. If you actually have another way you hold this guy, are you getting it? You are still going to see it there. Are you getting it? I think we will look at a very good example to explain this thing, maybe when we move forward. So let's look at the key difference between this stack and heap. So in the memory size, a stack is very little and very small. Heap is very large and flexible. The time span of data, this one is short-lived, just a function scope. After the function has been done, it is done. It's going to declare it, and it's long-lived until the garbage collector collects it. So accessible, it's fast and direct, slower and valve reference with references. Like this guy now, it is reference. I'm going to explain more additional example to understand very well. We have storage also. They have local storage and function. It's stored in local variable and function call, and this one is stored in object collection and closure. Now in management, it's automatically push and pop. Also this one is also automatically, it's automatic valve garbage collector. Now you don't do the two. Yeah, that is the truth. You don't do the two. You just need to assign your variable and remove a variable. But this one is done by automatically, as your function is running, is moving automatically. But this one is done by variable collector. So this one we need to wait. If the function is requires something, you need to remove it. If it's not required, you need to continue it. So let's look at another example. Now this is another example. Direct heap and garbage collection. That automatically manage memory for objects allocated in heap. This process freeing memory that is no longer in use is handled by that garbage collector, which is called GC. And garbage collector automatically free objects in the heap. I've already read that. So in this example above, P is set to none, and the person object previously referred to be by P become unreachable. This makes it eligible for garbage collector to reclaim its memory eventually. So now by adding none here, it helps garbage collector to say, oh, you already done it, and say you're not using it, that's why you call this none. So you can actually reclaim it if nobody is using it again. But if someone uses it, you can say, oh, you can reassign values to it. But if nobody is using it, you can it's easy for you to reclaim it immediately. Now it's important to know that heap object can be shared across different functions. This one takes another thing you need to learn and we need to master very well. Across different function parts of your program, if there is reference are passed around, this allow the complex data structure and persistent data. Now let's look at this example of heap. Now I'm going to copy this guy to heap. I'm going to paste it here. Now one other thing I want you to look at, this guy is stored in a stack. Now I'm going to use a lot of analogy here. This guy is stored in a stack, which is this A, and this guy list of objects is inside of the heap. This guy is stored inside of the heap, and the reference is inside of the stack, which is the name that is there. Now let me explain very well. Let's assume that we have what is called a house here. Now we have what is called street. You call it S or streets. Now our read data here is stored inside our house. It's in our house, but this A is on the street. Like maybe you have just put something in front of your house or on the street. Let me just on the street that can be accessible easily for anybody. Now you have, and this, which is this name, is the one that is the address to the stack. So this guy is the address. This guy is not the real object, but is the reference to the address. Anytime you want to access the stack, what do? You call on the reference, which is the one that is here on the stack. So this one is also on the street to be accessible. But this guy, what it does for us is that it helps us to go into the memory. Like it is stored on the memory to be able to assign to, able to know it or what it's doing. So, but what this guy does is he helps us to go into the memory of H to go and check it there. Now, let's look at this. Let's look at this guy and let's look at this example. And we need to run this guy. So let's run this example and with something. Okay, we thank God that it's not even running. So we are going to look at this. Look at this guy. I'm going to have what's called H. This guy is in like this. So this is a stack. Oh, sorry. This is actually in stack. A list like this. Now, this one also, it will be stored inside the stack. But inside the stack, what it is doing inside the stack is not just to be stored like storing number. It's storing the reference. It's storing the link or the access to the data that is there. So it's going to go to this place also, so which is house. So now what happened here is that there's something also happened, which is we have a function there. This function that is here basically has a parameter called list. Inside the list we have what is called a list that's also here. So we have a list also that's also called, that's also here. So what this list does for us now, look at what happened. Inside the mail we create an object, right, which is a list of data. And inside of this guy, what we did there is that we are adding, there's a list that is here. Now this list, as soon as you assign this num that is here to the list that we put here, it's also referencing to this guy. So this guy is referencing to this guy. This guy also is now referencing to this guy. So what now happen? As soon as we are done here, this list that is here, we call what called add. Now, if you want this code, now, you're going to see that it's going to add this 4 to 1, 2, 3. So let's run it. I'm going to exit the code here, and I'm going to run it. Wow, yeah, it's not printing anything. So let's print it. Let's say print num. So can you see it has added 4 to it, even though we are not adding by adding what is called norms like this. So for this guy for you to actually understand this thing more, so let's allow us to can that list. This is a new object entirely that I'm creating. Int. I'm going to call it new num is equal to, now I'm going to call it that, I'm assigning this to this guy. Now inside the new num, I have a new num, a dot add, add 50 to it. Now, you know that I'm not printing new num. You can say, no, I'm not printing new num. I'm not printing the num. But if I run it, it's going to add the 50 to even the num. You can see 50 has been added to the num. So now what does that mean? When we did this guy was created in the memory. Let me create very well. Was created in the memory. This guy reference to it. So when it comes to this guy is just a reference. It's not read the real data. It's just the reference to what is inside the memory. So you assign the reference also to this reference. This also is not the real data is the one that you save here. So you assign the reference to this reference. So this reference also is also automatically referencing to this guy. So also here also, this also is not the real data. I told you that the real data is the object that is in front of it, the value. So this also is referring to this data. So as soon as you add with this, it affects the num, the real data. So anything you do with this guy, it affects the num. Anything you do with this guy, it affects the real data. So all of these are not inside the heap file, inside the heap storage. They are just on the stack storage. All of these are just stack. So all of them, what you see here that makes it to be like different is because it's on the stack. That was it keep the memory or what is there. So the real data that is inside of the heap is this guy. So let's go and read our textbook. So here is primitive integer and directly stored on the stack. However, num is a reference, a pointer stored on the stack, which points to the actual list of integer objects residing in the heap. When modified number is called, the list parameter inside the modifier receive a copy of this reference. Now, it does not take the copy of the object, it takes the copy of the reference. And both nums in main and list in modify are now points to the same list. That would happen. And also what I also did here is that both this guy, new num, the names, all of them are pointing to the same list. The same list. Therefore, when add 4 is executes, it modify the heap object directly after it. So I hope you understand that. And the change are visible in main. Num will now be 1, 2, 3, 4. So
pointer. And that's how leave actually work. Let's summarize what we have learned. To understand how memory management works is essential for writing an effective and robust code. Let's break down the core concept of stack, heap, and garbage collection in a single way. Imagine a stack as a plate. So the one that you had last is the one that I remove first. Every time a function is called, a new plate is called, or a new plate is added to the stack. So a plate holds a local variable for the function, for that function. So when the function finishes its job, the plate is automatically removed from the stack. So what does that mean? Now, this function that is here, which is called modify, that is here, as soon as it's done with what it's doing, it is removed. So as soon as it is done, it removes itself. You add this one, so it removes after it's done. You have this one, it removes after it's done. So that is what we call the out. So a stack is fast and simple, but it's only for temporary, short-lived data that disappear when the functions end. So anytime you create a stack, now then the function ends, it disappear. So that was stack. Let's look at heap. Heap a storeroom for an object. Now think a heap as a large storeroom where a bigger or more complex object might live. Now, objects you create at runtime, like list, class, or other types, they store here. Unlike the stack object, in heap stick around until they are no longer needed. So what happened to stick is that heap actually stick around. They are actually there until, like normal the way stack actually work. As soon as you put it there, when it's done, it remove itself. But heap is going to stay around until, oh guy, I'm not using it again, or the code is done execution. So if your code is still alive and you have created a heap file, a heap object, it's going to be there until there is no reference point, or there's no pointer to it again, or you don't use it again. That's when garbage collector is going to remove it by itself automatically. So this allows a different part of your program to share and work with the same data over a long period. And then look at what is called garbage collector. So garbage collector, as I call CG, is like a helpful background assistant for heap. So its job is to automatically find and free up a memory occupied by objects in the heap that are no longer being used or referenced by any other part of the program. So the process help prevent a memory leak. Where your application holds some memory, it's actually when it's longer than needed, which can slower your data or even crash your application. So garbage collector is going to look for that kind of memory, that kind of data that is not in use or that's not necessary. It's going to remove automatically. So you don't have to manually delete objects or this other thing. You just need to remove it from it. And what you're actually learning here, when you get to a program that you're going to need to take over garbage collector and use them by yourself, it's going to be very easy for you to also. Now, let's look at what's it called object in and object out. Now, when you are creating an object like a list and or a class instance, so object in essentially like whenever you create an object, so the object itself is allocated to a heap automatically. That's what we call moving into the memory. Or so when object in, whenever you create an object that is allocated to the memory, you call the object in. So now other thing actually reference to the object. That can reference to the object was already object has been turned in. Now objects are removed from the memory when they are no longer reachable or when they are no longer in use. So that garbage collector detect objects that have no reference pointing to them and free the memory. This is like object out of memory. So then you hear object out. So what happens is that garbage collector is working behind the scene. Now, what is the key point? The moving in happen when you create a object dynamically. Memory in heap is used. So automatically your memory in heap starts being used as soon as you create your object. So move out is happen automatically via garbage collector when objects are no longer referenced. So this system prevents memory leaks and make memory management easy for developer. Now, you understand what is called heap? Heap is a storeroom. Objects moving when you store your something in the room. That's an analogy. So objects move out when you throw them away when you are not using them again. So, but garbage collector acts as your cleaner queue. Those that remove your objects. So now, so garbage collector sweep the memory by removing objects that nothing is pointing to. So your program does not run out of memory. So characteristic of this sweep happen automatically in the background. That's what you should know. In that it happen in C++, you need to do it yourself, but in that it happen in the background. You just remove by itself automatically. So it helps us to prevent memory leak. Only unreachable objects are removed unreachable object. Don't forget, object that is still in use remain untouched. So anytime you see your object that is unreachable, you remove it. What happens in memory whenever you update a data depend on the kind of data, on the type of the variable, whether it's primitive valued type or object, which is reference type. Let's break it down clearly. Primitive data type is int, bool, etc. Now, we have what is called int. And let's look at what happened here. We go back to our main here. So we're going to look at this integer that is here. Now, we have what is called age. Now, if my age, if I call it what is called age now, is equal to what is called 20. Now, what happened to my 12 is that my 12 will be removed as if it never exists. And when they store it here, before it gets it, will store all this thing that is here. Even if you use it, it won't come down to come and check it. But when it gets here, you will never have access to the top again. A new object is created for a basic primitive type. So anytime you update a new object like this, a new object is actually created, a new thing entirely is created, a new data type. As soon as you update it, that new thing has updated. So as I add this thing to it, what happens in our memory is that it disposes this thing. As soon as it gets to this place to add a new one, it disposes one that is there and it put the new one to it. That's what happened to it. Now, what happened here is double. Now, what happened here in reference type is that whenever you create a var and list like this, here you're updating the elements inside of the created heap, the one that is already in your heap. And when you create a new one here, you are assigning a variables. Now you're not updating as it were. You might think that maybe I'm updating a variable, but what happened here? You are creating a new object entirely you are saying that, oh, what is here inside of the heap, I don't need it again. Let me copy this and bring it into our project so you can understand very well. So let's look at this guy. So now here, I told you that there is a storage which is called heap. A storage which is called heap. Now, when you create an object, a heap is created, and this is a reference type. You are aware of that, right? A reference type. Now, in our reference type, we look at the reference type. We say inside my reference type, when you get to the heap, look for the one that is in 0 position and assign text to it. This one updates the same reference. Update it. Now, when you try to do this, now you may think that you are updating a new variable. No, what you are doing is that you are saying that this guy, I don't need this guy again. I want another variable like this. So you are creating a new heap object also here. So as soon as you create this, you cannot access this guy again. Now what happens is going to be that garbage collector is going to take this one and squander it and give you a new place entirely to create your data. So you're going to have a new storage, a new memory to put your data inside, and garbage collector is going to take this for you automatically. So we are getting all those native like what this means is that as soon as you assign a new data to it, you are actually having this list to be a new memory entirely. So this guy is now listening to it. So this list that is here cannot come here. No. But this is a new one from here. Are you getting it? So let me have two data like this. I say this is new data and new data. Now, this list can come here, or will come there. Now, as soon as you reassign, you do what's called equal to and assign a new values to it, this list will not come here again because automatically this is the list that is now available in your memory. These two lists will be disposed. This guy will not exist again in the memory to come to the new variable that you have created. So it's reassigning the variable, like you are reassigning the variable, not like just like updating. You're actually reassigning the variable just like this. So this is not also just updating, it is reassigning the variable. So that's what we are doing here. So you should understand that very well. So you can update primitive data type like this. What happens in the memory is that it replaces in the same stack location. Now, Updating an object in list like this, it modify a existing heap object. So this, you assign a object. What happens is the points variable of and the points variable to a new heap object. Old object will be handled by garbage collector. Old object may be garbage collector and be handled by them. So what happens is that whenever you create a new one like this, you are saying, oh, the old one, I don't care what you are doing, but this is the one about. So garbage collector is going to delete that one by itself. That's what that's going to do for you. So primitive data type are like they can change. They're like changing the number written on the stick. Like you're changing the number that you write on your notepad. But objects is like updating a item inside a box versus throwing the old box away and using a new box. So now let's look at what's called updating variables. When you are assigning a new variable to a variable, that intelligence updates the memory reference. This periodic value, if no longer needed, become eligible for garbage collection. So garbage collection is going to take that and make use of it and dispose it. So now let's look at this. So initial message is actually pointing to what is called a main, and this is going to make sense for us. So that is what's called a string. So so you can easily update what's called a name to what is called Ade Ade. So guys, there's a name to Ademola Ibukun Mayowa. When you print it, I'm going to give you Ademola Ibukun Mayowa. So this is how you update it. Now what is going to happen here, because this guy is on stack currently. I get here now. String are basically, if it's operator is going to basically treat as a stack memory inside your stack memory. As soon as you update it, you need to update it right away. So let's run it. So this is how you update a data, and I hope you have understood updating of your memory and your stack memory. So let's move forward. So what was called a data type? Primitive data type, object, and none. So all data type in that are technically objects, a simple value for efficiencies. So common example is integer, which is whole number or negative number. The one also is double. They are floating number, which is decimal, have decimal points. You have Boolean, which is true or false, can either be true or false. You have number that can either be int or double. So they are immutable. It creates a new value rather than modifying the existing one, and used for basic operation like arithmetic and logic testing. That's what you use them for. So let's look at object data. Is that they are instance of a class, including built-in or custom class. So stored in a heap, variable holds a reference to the object. That is object data type. Now example is string. Most of them, I told you all of them, most of them are object. List are what's called order collection. They are what we call order collection, like one, number, two. We have map. They are key and value pair. You say, oh, A is equal to 1, B is equal to 2. Anyhow, you have set a unique. All this one, they are stored in the heap memory. So they can have property like attributes inside of them, and they can also have method, which is called like functions. They can be mutable, they can change. They, their internal state can change or immutable, depending on how they are being created. So objects remain in memory until there is no reference point to them. At each time, the garbage collector. Now, a none is a special type of absence of data. Primitive, a stick note with a single number, yes or no, written on it. So object, a box collection, a box containing item, method, and variables, and multiple values. And none is an empty box. Now we have operator in that. Number one operator I want to talk about is called arithmetic operator. These are used for mathematical expression. Now you're going to write all these experiments one by one for me by expression and use what they are done for you. And this is comparison operator. Now I'm going to use this. All these guys, you're going to use them by yourself. Plus, minus, asterisk, division. This one by adding this sign is going to make it to turn to integer. So this one is 0.5, you want to be you want to be just 2. This one is remainder, say 2, remainder 2, you want to remain 1 after that divided by 2. 2 plus plus is to increase a value by 1. And let's have this operator before we go. So number one thing that we need to do is that we have what's called print. Now, the first operator that we need to look at is what's called equal to. Now, to say equal to, now what this equal to does, let's say, use to compare a value and return a boolean. Anytime you use this comparison operator, it's going to use to compare to actually compare a value and return back true or false for you, either true or false for you. So if I say 2 is equal to 3, it's going to give me true. Now it's not is equal to, this is what I use now, is an assignment operator. Assign it. If you want to say equal to, you need to have what's called double equal to like this. That will make it to be equal to. Now what I'm going to do, I'm going to run it in that. Now I have not taught you how to run your code in that. I've only taught you how to compile your code, but you can say compile it now. So we learn how to run it in that in our next class. So I'm going to run like this. So can you see it said true? Now, next thing we need to look at is it greater than or equal to 3? Also, you're going to give me true. So I'm going to have what is called print. So we have another true. So let's have another thing. So which is, let's look at our textbook. You have greater than. So is 3 greater than 5 greater than 3? So that is true also. 5 greater than 3. This should be false. Is 5 less than 3? You have less than. Is 5 less than 3? This will be 4. We have what is called greater than or equal to. This one to check. Is it greater than or less than or equal to? That means less than or equal to first. Is it than or equal to? It is false again. Let me use greater than. So it's going to be true next. Now we have what is called less than or equal to. Then let me see the last thing that is there. Less than or equal to, yeah. Let's run it. Let's compile. So that's execute. So can you see? They are all giving me true or false value. Now let's continue and have, there is last one I want you to look at. These are what we call non-method actually. So for you to be able to, like a method, a useful method that you need to learn and take one. These two guys, they actually work on number and double. So what we're going to do, I'm going to just use our age to do experiment. Say print. Now I want to use just number minus 6 dot absolute. I say absolute like this. Now this is going to give me, and this is going to give me an absolute value, which is going to be 6. And if I run it, and then another thing we need to also learn, so let's look at our list. Let me look at we have what's called ceil. Now what ceil does is not round up. Ceil does not round up. Ceil, okay, I guess that is round up. Okay. Ceil round up to, see what side does is round up everything to, even if it is 1, from 1 to 0, it round everything up. That was ceil does for us. And floor, we round it down. So even if it is 9, you want to round it back to 3. Now, the round up to the nearest one is what's called round. This is what's called round. So if it is 5, you round it to 4. If it is 4, you round it to 3. Now, converting to integer, dot to integer, dot to integer, you want to remove anywhere you see dot something, you want to remove it from you. Now, if you say convert to double, so I want you to type everything one by one and see. And you can also check if it is even and if it is, so you can say dot even. So I guess you cannot have what's called this dash here. You cannot have dash there. You want to check if it's even. But that's by the way. So you can check if it is even or if it is odd by just accessing what is called dot something. This dot starts like accessing the method that is inside of it. That's why we call it what's called run method. You know, part of your assignment, you need to practice all of everything for me. Now, so another thing that you need to learn is what's called um, Boolean logic. And these are just three things that we need to learn. You have what is called AND. Now, if you look at AND, anytime you have what's called true and false is equal to false. You have true or false is equal to true. You have not true is equal to false. So let's practice it. Let's say we have what's called print true and true. This is true. True and true is true. True and false is false. So true or false is true. True or false is true. And it's not even, look at this. Also, it said it is identical because it cannot be reached. It's going to be true. And say print. What other thing that is there? Yes, not true. I say print not true. Now, if I run it, I want to see that we need to have not true. So true and true. This is true. This is true. This is true. This is true. Now, true and false is false because the two of them are not true. Anytime you have what's called and like this, the two of them have to be true for it to make one true. But if you have true or, if this one is true or is that this one of them has to be just true before it can be true. So this one now, it says that this guy and this, the also they are false, this one are true, this one are false, this one are true, and this one are false. So that is how to, this is what false and true means. So you can practice it with this example. Now, this is just the recap of what we have learned today. So we have learned what is called data accessibility, automatic memory, and then about memory, data category collector, and memory management, being used for focusing and writing a powerful application. So essential entry point where every data program begins to its execution. Variable and data type, learn that one, fundamental of storing and manipulating different kind of data within your program. Efficient comments, we learn how to crucial for documenting your code and making it clean and maintainable and understanding for everyone. So we have memory behavior, how primitive and objects are behaving in your memory. So that's what we have learned. So we need to start practicing this before we continue on Wednesday. Thank you.